Hello dear students and learners. In this video I'm going to start a new chapter, the first chapter of NCERT Chemistry Class 12th, the solid state. As you know, there are 5 states of matter. These are solid, liquid, gas, plasma and Bose-Einstein condensate. Okay, and in this video we'll start the introduction paragraph of the first chapter, the solid state, and first we'll look at the key points, the objective that we'll go through this chapter. We'll discuss about the characteristics of solid state. We'll distinguish amorphous solids and crystalline solids. Then we classify crystalline solid on the basis of nature of binding forces. We'll see units, what a unit cell is, crystal lattice, packing fraction, deficiency, imperfection, physical deficiency, and the electrical and magnetic property of solid and their structure. Okay, so these are the objectives that we have to go through. Okay, so we'll start the first paragraph. As you know, in this chapter I'll explain you line by line NCERT, so we'll continue that. So from our earlier studies we know that liquid and gases are called fluids because of their ability to flow. You know, liquids and gases are called fluids because they can flow. As you know, they don't have a definite shape because their particles are free to move, while in the case of a solid, the particles of solids are have a fixed position. That's why solids are rigid. So the fluidity in both of these states is due to the fact that the molecules are free to move about. On the contrary, the constituent particles in solid have fixed position and can only oscillate about their mean position. Okay, this is what I explained you. This explains the rigidity in solid. This property depends upon the nature of constituent party and the binding of forces operating between them. And the force properties of solid, on what basis, what are the factors on which the properties of a solid, like you see a rubber band, it can be stretched. Iron, it cannot be stretched. So how these two solids are different, this depends on the particles that constitute them. Okay, and the binding forces. Okay, you see in solid there is intermolecular force, in matter there is intermolecular force, and in solid the intermolecular forces are the strongest. Okay, so these are the two factors on which the properties of a solid depends. Okay, the correlation between structure and properties help in the discovery of new solid material with desired properties. Okay, and there is a relation between the structure. Okay, how the particles are arranged. Okay, particles are arranged and properties uh, with the structure and properties of the solid. Okay, how the particles will be arranged in a solid, then it will decide the structure and properties of the solid, and it will help to understanding the structure and the arrangement of the particles, and then the insertion of new particle, the impurities will help us understand to make new materials, to understand the properties, and to get new materials, that desirable materials. Okay, like we'll see an example here. For example, carbon nanotubes are new materials that have potential to provide material that are tougher than steel, lighter than aluminum, and have more conductive property than copper. Okay, so you must have heard about carbon nanotubes. We have the desired property that we want. Like we want material tough material. You know, steel is a tough material. Carbon nanotubes are even tougher. They are lighter than aluminum, and you can see here copper is a conductor and they are good conductors. So we got a material, carbon nanotube, that have all the desirable properties just by changing the structure. Okay, structure and choosing the right material. Okay, so we'll see further in the chapter how we are going to get material, desired materials. Okay, first of all we have to understand the arrangement of the particles in a different arrangement of particle in different solids. Okay, so now such material may play an expanding role in future development of science and society. Okay, obviously this is a very obvious point. Okay, so we are constantly improving in our devices, improving the materials. Okay, we want like this carbon nanotube is one example. Even you see the bicycle, okay, the carbon fibers, they are made of carbon fiber and they are very light. Okay, most of the things are made of like this carbon fiber, they are very light. So this kind of material, they help us to make our devices of good quality, lightweight, okay, durable, okay, and that's why they help us those development of science and society. Some other materials which are expected to play an important role in future are high temperatures superconductors. Okay, so superconductor are, you know, are the materials which have no resistance at all. But what we are going to try, we are trying to make them high temperature. Superconductivity is only achieved at low temperature, but it is our it is on the it is our effort that we are able to, we're going to achieve high temperature superconductors in the near future. Okay, then even at room temperature we will get conductors that will have no resistance at all. Okay, now in magnetic materials, biodegradable polymers, okay, for packaging, okay, you see polymers like polythene is a polymer, but it is not biodegradable, and that is a very big concern to the nature. So in our future we are trying to make biodegradable polymers, okay, for packaging, okay, compliant solids for surgical implants, okay. So these are, we have different aspects of this, okay. So we are definitely looking for better solids, okay, and with the desirable properties. Thus the study of this state becomes more important in the present scenario. So you see this as a very important application. So we need to, first of all we need to understand the structure of solid, different structure of solid. Only then we will try to merge them, okay. Then we will get all the desirable properties of one solid. Like if we want the elasticity of rubber band, we have to understand the how, why the rubber band has this elastic nature, what are its constituent particles, what is the arrangement, okay. And then we also want the conductivity, like in case of copper, then we have to understand the nature and the arrangement of particle nature. Then we will try to get a material that will have both the properties, okay. I hope this is clear to you. This is an important point. So what is the base of this chapter? First of all, we understand the base of this chapter, okay. Then all of the things will become very easy for us. In this unit we shall discuss different possible arrangement of particles resulting in several types of structures, and explore why different arrangement of structure lead different properties of solid. Okay, already told you this line is important, okay. We will also learn how this property can modify due to structure imperfection, okay. We'll try to make it we will add impurities in it, different material, different atoms, and the property will get modified, okay. You'll see later in the chapter what are the presence of impurities in a minute amounts, okay. You have seen a doping in physics, you see in class semiconductor you will doping. Similarly it will happen here, okay. So this paragraph just gave us the idea about the whole chapter, what we're going to study in the whole chapter, okay. I hope I was able to make you understand this paragraph clear. And in the next paragraph, next video, I'll explain you article number 1.1, general characteristics of solid state, okay. uh, I hope this my explanation was clear to you. If you like the explanation, please let me know in the comment section, hit the like button, and um, I'll tell you we'll meet in the next video. Thanks for watching.